So, question 2 in worksheet B. Find the point on the sphere x squared plus y squared plus z squared equals 4 furthest from the point 1 minus 1, 1. So the furthest point. Now, to do this question, furthest point, and they tell you use Lagrange multiply. So first of all, you need the function that you're finding the furthest, meaning maximizing. You're maximizing a certain function. And this function is the distance between the curve and this. So that would be x minus this squared, y minus this, y minus minus becomes plus squared, and z minus 1 squared. This is the distance function under the square root, but doesn't matter. We can call this your f function that you're maximizing in terms of x, y, z. Your g function is this one here, x squared, y squared, z squared, minus 4 equals 0. Like we did for the question in worksheet A, we find the gradient for f. The derivative with respect to x would be 2x minus 1. The derivative of this with respect to y would be 2y plus 1. And the derivative for this would be 2z minus 1. The gradient for g, the derivative of this with respect to x is 2x. The derivative of this with respect to y is 2y, and this is 2z. You take this one, 2x minus 1, and you make it equal this times lambda. And you take the second one, 2y plus 1, and you make it equals 2y lambda. And you take 2z minus 1, and you make it equal this lambda. You'll see you can cancel the 2. Okay, I'm gonna erase some of this. Well, I can continue here. From the first one, lambda is x minus 1 over x. If I plug this here and here, y plus 1 equals, instead of lambda, I go x minus 1 over xy. And I plug it here, so z minus 1 equals, instead of lambda, we go x minus 1 over x and z. Okay, I'm gonna just erase some of this. Now, if you consider the first one, so I should put it here. Lambda is x minus 1 over x. If I take this equation, y plus 1, x over x is 1, minus 1 over x. So what I did, x over x is 1 minus 1 over x times y. So y plus 1 equals, take this inside, that's a y minus y over x. bring the y over there, so you have y plus 1 minus y equals negative y over x, cancels, so y equals negative y over x, so x equals negative y. That's from the first equation. If I consider the second equation, if I consider this equation here, same idea, z minus 1 equals x over x is 1, 1 over x is 1 over x times z. Z minus 1, take this inside, z over x. You bring the z over, z and z cancel, do the cross multiplication, negative x equals negative z, or x equals z, basically. So, x equals z and x equals negative y. Or y equals negative x, basically. So, after you do this, you plug everything into the constraint, into this one. X squared, leave it as it is. Y squared, I can use minus x squared. Z squared, I can use x squared minus 4 equals 0. This is x squared plus x squared plus x squared minus 4 over is 4, so 3x squared equals 4, x squared equals 4 over 3. If x squared equals 4 over 3, x equals root 4 over 3 or minus root 4 over 3. Which is 2 over root 3 or minus 2 over root 3. These are the possible values for x. If x is 2 root 3, then y is minus x, so minus 2 over root 3, and z equals x, 2 over root 3, so we have this point. 2 root 3, negative 2 root 3, and 2 root 3. If I take x of minus 2 root 3, then y would be minus of this, turns into positive, and z equals this. So that would be point number 2. Which is negative 2 root 3, 2 root 3, negative 2 root 3. So once you have the 2 points, you plug them back into your main function, the f function. And the f function was the distance. So you plug them back into this one. So you plug the negative 2 root 3, 2 root 3, minus 2 root 3 into this function, and also negative 2 the first one is the positive, negative, positive, and the second one is negative, positive, negative. You plug them all into this function. So it's a headache. I don't want to waste time, but basically it would be 2 root 3 minus 1 squared, negative 2 root 3 plus 1 squared, and 2 root 3 minus 1 squared. This would be minus 2 root 3 minus 1 squared. This would be positive plus 1 squared, and negative minus 1 squared. I'll use the calculator to do it because it's just a lot of numbers. So easier if I just use the calculator. The first one is 7 minus 4 root 3, which is about 0.72. If we use the second one, we get 7 plus 4 root 3, and that's about 1393. That means that this point is the minimum, and this point here is the maximum. Okay. Question 3. Double integral for the region ex plus y dA, x between 0, 2 and y between 0, 1. For a continuous region, it doesn't matter how you do it, x first or y first. I'll do the x first. Ex plus y dx dy. If you do the dx of 0, 2 first, and you do this 0, 1. I'm also going to do the other way. Ex plus y. I'll do the dy and then the dx, so the dy 0, 1 and then 0, 2. The integral of this would be itself and over basically nothing, because think about it, if you integrate x plus 1, it will be x plus 1. So the integral of this would be just itself over the x multiplier, which is 1, so it doesn't really matter. So you need to plug 0, 2 for x, and then integrate this from 0, 1, y. Put the 2, so that's 2 plus y. Put the 0, that's e to the y. Now we integrate this with respect to y. This would be itself, this would be itself, and 0, 1. 1 will give you e cubed minus e to the 1. Put the 0, e squared, e to the 0. So the answer is e cubed minus e squared minus e plus 1. This if you do it x first. Let's see what happens if we do it y first. Integral of this would be itself 0, 1. And then we integrate it with respect to x. You plug 1 for y, so that would be x plus 1. Put the 0 would be ex, and then you have a dx, 0 to. Integral of this is itself. Integral of this is itself. And you put 2 and 0. Put the 2, e cubed minus e squared. Put the 0, e1 minus e0. So it's e cubed minus e squared minus e. E to the 0 is 1, minus 1 plus 1. And if you see, it's the same answer, so it doesn't matter how you do it, dx first or dy first. The last question is also an integral. That's question 4, sheet B. 0, 1, 1, 2, x outside, and then they want you to do the dx and then the dy. Exponent here is 5. Okay. To do the dx, the integral of this is a little bit complicated because you have x inside and you have x outside, so we have to do with u sub. I'm going to let u be 1 plus xy. Then I'm going to solve for x, so it'll be y minus 1. Then x is u minus 1 over y. I also need to find my du. Derivative with this with respect to x. Everything is with respect to x, would be y dx. So if I only do this part, instead of x, I'll use u minus 1 over y, which is a constant in this case. The inside, I'm calling u, so that's u squared. And dx, which is this one, is du over y. Y times y is y squared, and since that's a constant, that's 5, sorry. Since that's a constant, I can take it outside the integral, so I only have this to integrate. Take u5 inside, so it's u5, u6, u5. So 1 over u squared, that's 7 over 7, 6 over 6. Now, I have to put u back as it is. So the answer, instead of u, I put this, so I have 1 over y squared, 1 plus xy, that's my u, to the 7 over 7. Instead of u6, 1 plus xy, 6 over 6. And we have the 1 and the 2. So, since we did the x first, anywhere you see x, you plug 2. So that would be 2y to the 7 over 7. You plug 2 here, 2y 6 over 6. I'm gonna erase some of this. Minus, so it would be this minus, you plug 1, it would be 1 plus y 7 over 7, and you plug 1 here would be 1 plus y 6 over 6. That's the integral for this question. You still need to integrate this from 0 to 1 dy, which makes it even more complicated, because now, well, not really, but it will take more time to do it this way. Another way that I'm gonna try to maybe see if that will make it simpler, because really it's very complicated this way. So I'm gonna switch the x and the y, because I know that it doesn't matter. So if I switch the x and y, if you do this integral with respect to y, all you need to do, because everything else is a constant, it would be 1 plus xy 6 over 6 over the constant of y, x, so cancel, cancel. So you have 1 plus 6y 6 over 6, and you have 0 and 1. You see, it's much easier if you do the y first. So now you put 1 for y, so that turns into 1 plus x 6 over 6, and you put 0 would be 1 to the power 6 over 6. That's the answer. You can integrate it with respect to x. So maybe he wanted you to see that integrating this the way it is hard, and maybe you need to flip. Integral of the first one, you add 1 to the exponent over 7, and that's a 6, so 42. A constant would be a constant x. You plug 2 and 1. If you plug 2, it would be 3 to the power 7 over 42 minus 2 over 6. Minus, if you plug 1, it would be 2 to the power 7 over 42 minus 1 over 6. So if I do this quickly in the calculator, 3 to the power 7 minus the fraction, and then 2 to the power 7 minus 1 over 6. I get this answer. It's 2058, or as a fraction, it's better to say it's 12353 over 6. This is the final answer for the integral, but it's better to switch the x and y, makes it much simpler. This is it for this worksheet 7.